question of precisely defining a structure within the context of electrical codes. Specifically, Article 225.30 isn't explicitly detailed in the provided text. The general definition of a structure leans towards anything that is built or constructed. To properly interpret and apply Article 225.30, it is important to understand its intent and how it relates to other sections of the National Electrical Code, or NEC. Article 225.30 deals with the number of supplies to one building or other structure. It restricts the number of supplies to ensure safety and prevent overload or confusion in electrical systems. To clarify when something qualifies as a separate structure, consider several factors. Firstly, physical separation. Are the buildings physically detached? If two buildings stand apart with a clear separation, they are likely considered separate structures. Secondly, usage. Do the buildings serve distinct purposes? For instance, a house and a detached garage or workshop may be considered separate structures if they serve different functions. Thirdly, ownership. Different ownership could also indicate separate structures, even if the buildings are close. However, this isn't always definitive. Fourthly, the presence of a disconnecting means. Each structure usually requires a main disconnecting means for the entire electrical supply. This is often a key factor in determining if it's a separate structure. Fifthly, consider the overall electrical system design. The NEC aims to ensure safe and reliable electrical installations. If treating two closely connected areas as one structure compromises safety or creates potential hazards, they should be considered separate structures. To get a more precise interpretation, consult the NEC Handbook and local electrical inspectors. The NEC Handbook provides detailed explanations and examples to clarify code requirements. Local electrical inspectors can offer guidance specific to your location and project. Also, consider these additional points. 1. Review Article 100 of the NEC, which contains definitions of terms used throughout the code. While it might not explicitly define structure, it may provide related definitions that offer clarity. 2. Examine other articles within Article 225, such as Article 225.31 and Article 225.32, which discuss disconnecting means. These articles might indirectly shed light on what constitutes a separate structure by specifying requirements for each structure. 3. Remember that the NEC is updated regularly. Ensure you're referencing the latest edition of the code to stay current with any changes in interpretation or requirements. 4. Case studies and examples can be helpful. Research similar scenarios online or in electrical trade publications to see how others have interpreted the code in comparable situations. 5. When in doubt, always seek clarification from a qualified electrical engineer or inspector. Their expertise can help you navigate complex code requirements and ensure your installation complies with all applicable regulations. 6. Documentation is essential. Keep detailed records of your interpretation of the code, consultations with experts, and any relevant documentation related to your project. This can be helpful in case of future inspections or questions. 7. Understand the concept of building versus structure. While often used interchangeably, the NEC might differentiate between the two in specific contexts. A building typically refers to a structure with walls and a roof, while a structure can encompass a broader range of constructed items. 8. Consider the implications of treating multiple buildings as a single structure. This could affect the size of the service entrance, the number of feeders required, and other aspects of the electrical system. 9. Be aware of any local amendments to the NEC. Some jurisdictions may have their own specific rules or interpretations that supersede the national code. 10. Remember that the primary goal of the NEC is to ensure electrical safety. Always prioritize safety when making decisions about electrical installations, and err on the side of caution if you're unsure about the proper interpretation of the code. 11. Think about the future expansion or modification of the electrical system. If you anticipate adding more load to one of the buildings, it might be prudent to treat them as separate structures to provide adequate capacity. 12. Consider the impact on emergency systems. If one of the buildings houses emergency equipment, such as backup generators or fire pumps, it might be necessary to treat it as a separate structure to ensure the reliability of these systems. 13. Pay attention to the details of the construction. The materials used, the methods of construction, and the overall design of the buildings can all influence whether they should be considered separate structures. 14. Consider the potential for future changes in occupancy. If the use of one of the buildings is likely to change in the future, it might be wise to treat them as separate structures to avoid potential code violations. 15. Remember that the NEC is a living document. It is constantly evolving to reflect new technologies, changing safety standards, and emerging best practices. Stay informed about the latest updates and revisions to the code. 16. Take into account the environmental conditions. The location of the buildings, the climate, and other environmental factors can all affect the design and installation of the electrical system. 17. Consider the aesthetic aspects of the installation. While safety is the primary concern, it is also important to create an electrical system that is visually appealing and blends in with the surrounding environment. 18. Think about the long-term maintenance of the electrical system. Make sure that the installation is designed in a way that makes it easy to inspect, test, and repair the system in the future. 19. Consider the potential for future technological advancements. As new technologies emerge, the electrical system may need to be upgraded or modified to accommodate them. 20. Always strive to exceed the minimum requirements of the NEC. While compliance with the code is essential, it is also important to go above and beyond to create a safe, reliable, and efficient electrical system. 21. Remember that the NEC is not a substitute for good engineering judgment. It is a guide to help you design and install safe electrical systems, but it is not a replacement for careful planning, sound engineering principles, and thorough knowledge of electrical theory. 22. Take advantage of available resources. There are many books, articles, websites, and training courses that can help you learn more about the NEC and how to apply it properly. 23. Network with other electrical professionals. Attend industry events, join online forums, and connect with other electricians, engineers, and inspectors to share knowledge and learn from each other's experiences. 24. Never be afraid to ask for help. If you are unsure about any aspect of the NEC, don't hesitate to contact a qualified electrical professional for assistance. 25. Always prioritize safety. Electrical work can be dangerous, so it is important to take all necessary precautions to protect yourself and others from harm. Always wear appropriate personal protective equipment, follow safe work practices, and de-energize circuits before working on them. 26. Consider the requirements for grounding and bonding. Proper grounding and bonding are essential for preventing electrical shock hazards and ensuring the safe operation of electrical equipment. 27. Pay attention to the labeling requirements. The NEC specifies requirements for labeling electrical equipment, circuits, and panels. Proper labeling is essential for identifying circuits and preventing confusion. 28. Consider the requirements for overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect circuits from overloads and short circuits. Ensure that the correct size and type of overcurrent protection device is installed for each circuit. 29. Be aware of the requirements for conductor ampacity. The ampacity of a conductor is the maximum amount of current that it can safely carry. The NEC specifies ampacity ratings for different types of conductors based on their size, insulation, and installation conditions. 30. Consider the voltage drop in the circuit. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for calculating voltage drop and ensuring that it is within acceptable limit. 31. Pay attention to the requirements for wiring methods. The NEC specifies different wiring methods that are permitted for different applications. Select the appropriate wiring method for the specific installation conditions. 32. Consider the requirements for box fill. The NEC specifies the maximum number of conductors that can be installed in an electrical box. Ensure that the box is not overcrowded, as this can create a fire hazard. 33. Be aware of the requirements for conduit fill. The NEC specifies the maximum percentage of the cross-sectional area of a conduit that can be occupied by conductors. Ensure that the conduit is not overfilled, as this can make it difficult to pull conductors and can damage the insulation. 34. Consider the requirements for spacing around electrical equipment. The NEC specifies minimum clearances around electrical equipment to allow for safe access for maintenance and repairs. 35. Pay attention to the requirements for working space. The NEC specifies minimum working space requirements around electrical equipment to provide adequate room for electricians to work safely. 36. Be aware of the requirements for illumination. The NEC specifies minimum illumination levels for working spaces and other areas where electrical equipment is located. 37. Consider the requirements for ventilation. Electrical equipment can generate heat, so it is important to provide adequate ventilation to prevent overheating. 38. Pay attention to the requirements for protection from physical damage. The NEC requires that electrical equipment be protected from physical damage that could impair its safe operation. 39. Be aware of the requirements for protection from corrosion. The NEC requires that electrical equipment be protected from corrosion in environments where it is likely to occur. 40. Consider the requirements for protection from moisture. The NEC requires that electrical equipment be protected from moisture in environments where it is likely to be exposed to water. 41. Pay attention to the requirements for bonding of metal enclosures. The NEC requires that all metal enclosures containing electrical conductors be bonded together to create a low impedance path for fault current. 42. Be aware of the requirements for grounding electrode systems. The NEC specifies requirements for grounding electrode systems which are used to connect the electrical system to the earth. 43. Consider the requirements for surge protection. Surge protection devices are designed to protect electrical equipment from voltage surges caused by lightning or other event. 44. Pay attention to the requirements for emergency power systems. The NEC specifies requirements for emergency power systems, which are designed to provide power to essential equipment during a power outage. 45. Be aware of the requirements for fire alarm systems. The NEC specifies requirements for fire alarm systems, which are designed to detect fires and alert occupants. 46. Consider the requirements for special occupancies. The NEC has special requirements for certain occupancies, such as hospitals, schools, and theatres. 47. Pay attention to the requirements for hazardous locations. The NEC has special requirements for hazardous locations, where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dusts. 48. Be aware of the requirements for swimming pools and spas. The NEC has special requirements for swimming pools and spas to protect swimmers from electrical shock hazards. 49. Consider the requirements for solar photovoltaic systems. The NEC has special requirements for solar photovoltaic systems, which are used to generate electricity from sunlight. 50. Pay attention to the requirements for wind power systems. The NEC has special requirements for wind power systems, which are used to generate electricity from wind. Remember, this information serves as guidance. Always consult the latest edition of the National Electrical Code and seek expert advice when making decisions about electrical installations.